All right, so how are you guys doing today? Happy week 3 of classes.
I am stressed out. That
Yes.
last part of the owl stressed me out.
The owls are very stressful, so that's why I really wanted tonight just to work on the owls. So I'm going to go back over if you guys have questions from owl 1, owl 2, and then we'll work through owl 3 tonight. Because to me, that's the hardest part is getting through those owls. Like I said, even like that's why when I made the recording, I started laughing. I'm like, it's funny that you even got to see me struggle with these stupid things. It's not because the questions are hard; it's how they have things worded. It's how they set up. It's not
put it in.
well, and that's where like probably to a publisher, this looks so easy. To every other person, you're like, why did they do this like that? Like, why can't this be multiple choice? Why can't this all be dropped down? Or why can't it be that you just type the answer? There's
and then like the one where you had the periodic table where you had to like go across and see which ones was bigger or smaller.
Yeah,
I was putting in it right, and I know I was putting in it right, but it kept on marking it wrong. So I'm like, what the heck is going on?
All right, let's go ahead and go back through those because like I said, those are such a owl is not. So this is what I'm going to do because I changed the due dates so now they're open. But what I'm going to do, I'm just going to make the due dates all set to be done at the last end of class. I do want you to work on them weekly because it will help you for the midterm and it will help you for the final. And it's also easier just to do them every week as opposed to having to do all of them at the very end. But I'm making it to where they're going to be just due at the end of the term because, like I said, there's too much stress going on with OWL, and it seems because we're not in class, so I can't be like, oh, here, let me see your individual OWL assignment. And it's so I'm like to ease some burden, I'm going to change the due date. So you're going to see the change fall to December, and with the idea that again, it's going to be you'll work on them as you go. Still keep working on them. I'm going to still focus on them. But it at least will alleviate some of that wanting to throw your computer out the window.
Is the midterm going to be anything like OWL?
So actually, I have not gotten access to the midterm as of right now.
Oh my God.
I know, I'm even stressed about it. So I texted Kelly and I was like, please, can I get can I get a hold of it tomorrow? So my goal is I'm going to keep the study guide that they gave you as is. Once I actually get the midterm, I'm going to go and say, okay, we're going to work on this, we're going to work on this, and we're going to work on this. And I'll actually make like a more in detailed study guide. The study guide they provided was actually really good. So I'm like, okay, I'm not upset with that, but I want to just put more detail into it. So, okay, really focus here, really focus here, really focus here. And I think that'll be the easier way to go. Because otherwise, it is so funny how the class is set up. 3 chapters, 2 hours, 1 day a week. I'm sorry, I have no idea. Like I feel terrible for saying that because I'm your instructor, but holy smokes, you guys have a lot to do.
Honestly, I'm really panicking about the midterm.
Don't panic about the midterm. So I will say this, the midterm is not usually a big part of your grade. It's only 10%. So you could bomb it and still pass the class. So just let that be an idea. But I'm going to try to prepare you guys as much as I can. The biggest thing is understanding the concepts. Now, what I will say too, and then hold up one. Let me do this really quick. All right, that way you guys can just hear me a little bit better. So when we go into the module, so I'm going to show you guys really quickly. Hello. And yes, if anyone can sign in, just write your name on the chat. So that way at the end, I can just scroll through the chat and I can throw you guys on the attendance sheet. So that way we're all good to go there. So don't forget to type your name at the very bottom. And if anyone comes in late and I don't catch it, just if you want to, I'll try to make sure I make mention before we leave. If you didn't sign yourself in, sign yourself in. So I have it written out. But if you go to module 3 in here, you'll see that it shows you this midterm study guide. So go ahead and start looking through there because this is going to be how the study guide's set up. Like I said, for right now, we will use this as a template, and then I will give you a little bit more in detail instruction when I finally get a hold of the key. I'm assuming I should have the key relatively pretty quickly. Like I said, I sent a message and I sent an email. So hopefully I'll get it at least by tomorrow so I can go ahead and start making a video and getting you guys ready for it. I'm also going to do some online tutoring again tomorrow night from 6 to 7 p.m. And then I'm going to do Thursday from 6 to 7 p.m. We don't have a lab this week. So it'll say module 3 in-person lab. We don't have lab this week. We have a lab next week, so we'll do 4, 5, and 6 will be our labs. So they'll be all right in a row. So no lab on tomorrow, but I will do like I said, an online Zoom from 6 to 7 if you guys can make it. Otherwise, I'll post the recording like normal. And then again, same thing on Thursday. So in case there's any questions that pop up during that time frame, you guys can either ask me on tomorrow or you guys can ask me on Thursday. But like I said, just kind of use this as a reference. Make sure you understand what everything is. And then you can also reference it with the OWL homework, just so to give you an idea of what to expect. I would also suggest you actually bringing this with you. So for your guys' midterm, I will allow you guys to actually use your study guide to take the exam. So bring this with you, print this off, and then also because it has a reference sheet, it gives you all of the pieces that we would need to know for your exam. So again, if you need a formula, it's on here. If you need to know, again, for conversion, it's on here. I would even write up at the top my little way of remembering it. King Henry died unexpectedly drinking chocolate milk. Write it on here. But you guys can use this for your midterm. Because again, I don't expect you to have these things memorized. So you can use this as for your midterm, practice with it, get used to seeing it, and that way you have it. And then you also have a periodic table as well. So you'll have the atomic number, you'll have the atomic mass, you know the symbols, you know the periods. You can definitely use this. And I think that that would be very helpful. So don't forget to print this off. I will make sure to have a couple extra printed for the midterm. But again, I would say get used to having it. You can make notes on it. I don't care what notes you make. You can have your notes on here. And again, then it'll help you for your midterm. So yes, like I said, for chemistry wise, I don't expect you to have all of this memorized in 3 weeks. There's no way. It's just not possible. Again, you'll get used to a lot of the pieces, but I don't expect you to have this memorized. So use this, write your notes on here. If there's something that maybe, again, helps you to memorize something or helps you to understand the differences, use this to your advantage. You can write on the back of it. Because again, you don't know what the final or the midterm looks like. So use this to your advantage for sure. And so, like I said, I may be the only class that lets you use a study guide, but for chemistry, again, because of the formulas, this is definitely, you can use this for your final or for your midterm exam. So you can find this right in the midterm study guide. Again, the study guide you can print off, and that reference sheet you can print off, and you can have it to use for your midterm. So I hope that makes a little bit more sense. But let's go ahead and let's get into the OWL homework. So I'm going to say, let's start back from OWL 1. If you guys have questions, we will go through it. We'll go through OWL 2, and then we're going to go through OWL 3. So are there any questions from OWL 1? And if you guys have it yet, just tell me the number. Like I said, they won't be verbatim what you have, but they'll be relatively very similar. So if I show you how to work it, again, if you kind of know that step-by-step formula, it should run pretty similarly. But are there any questions from OWL 1 that you guys have as of right now? And definitely speak up, because if you have a problem with it or have a question about it, you know someone else does as well. So definitely ask for sure.
I was actually wondering if there was any way that you could write out, or we could write out somehow, like the steps for like the main problems in there, because
Yeah.
that's what I was getting caught up on, was like,
The stoichiometry problems.
yeah, like I'm decent at math and I'm sitting there going, okay, I know I'm missing a step, but which one is it?
Exactly. Yeah. So no, perfect. So you can for sure, and same thing, I would write that on your reference sheet, like how to go from grams to moles, how to go from moles to moles, write that on there so you know exactly what to do. So do you have a specific problem, or just in general, like what are the formulas to do?
Just in general, I forgot exactly. It was towards the end of the OWL 1 homework that I was like, wait, there's like 7 different steps here.
Right. Okay. So let me do this, and then I'll kind of just go more general. And then we can go from there as well. So, all right, let me pull this up really quickly. And I'm gonna, actually, no, I'm gonna go here, because then I can do slideshow and I can make a blank screen. Okay. So first thing, like, for instance, if you have to go from molecules to moles. Let's just say hypothetically, because that was part of L1. So if you're dealing with a molecule, if you hear the term molecule or you hear the term atom, and it asks you to convert from moles to molecules or moles to atoms or atoms to moles or molecules to moles, here we're going to start thinking Avogadro's number. And actually, we already passed this day. We actually celebrate mole day. It's because it's 6.022 times 10 to the 23rd. And it's either atoms or molecules for 1 mole. So if you get a problem like this, let's just say hypothetically, you want to go from moles to molecules. The molecules is your hint. Okay, Avogadro's number. Or if you hear atoms, hint that you're going to use this Avogadro's number. So this guy here is your equivalent, meaning that we can either put moles on top or moles on the bottom, or atoms on top and atoms on the bottom. So let's just say hypothetically I had 2 moles and I wanted to convert it to molecules. Always start with what they give you first. So if they gave you that you had 2 moles of oxygen or 2 moles of carbon dioxide, we start with our 2 moles. And because we want to go to molecules or go to atoms, we will then put moles on the bottom. We'll say that we have 1 mole on the bottom, and we'll multiply it by 6.022 times 10 to the 23rd. Atoms or molecules. Again, it can be either one. The moles will cancel out, and oops, I hit the wrong button. Let me fix this. The moles will cancel out. And now you're going to be left with your number in atoms or molecules. So atoms and molecules should be a really big number. Moles should be a really small number. So again, if you want to write this just right now on a notebook, and then again, when you get your reference sheet, you can write this on there. That's fine with me. But it gives you an idea of how to sort of practice this. Now, on the flip side, let's just say hypothetically you start with molecules, and now you want to go to moles. Now what we're going to do is say, okay, I have 2.46 times 10 to the 24th molecules, and I want to get to moles. So I have to use that equivalent. 1 mole equals 6.022 times 10 to the 23rd molecules. Now, because I want to get rid of molecules, do I put it on the top or do I put it on the bottom here?
The bottom.
Bottom, very good, because I wanted to cancel out. 6.022 times 10 to the 23rd molecules over 1 mole. And then when I go to throw this in my calculator, I want to make sure that, again, this is in parentheses. So that way you don't get a really wonky number, because moles should be a small component. So that's how you would go from like moles to molecules or molecules to moles. Now, the fun thing is sometimes you're going to get where you need to go from moles to moles. So they'll give you moles of one piece, and then you need to get to moles of another. So let's actually look at some OWL homework really quick, and then we can go from there. Let me see. Okay, perfect. So if we get to like this question here, this is number 13 in the homework. So this is an OWL 1. This one says how many moles of nitrogen atoms are present in a sample that contains 3.66 moles of dinitrogen tetrafluoride. Now, this one's a little bit different, because what this is trying to figure out is how much nitrogen do you have in this compound here. So when we go to look at something like this, we're looking at how many atoms are present for this whole piece. So for 1 mole of this compound, this N2F4, there are 2 moles of nitrogen. And the reason we know it's 2 moles of nitrogen is because of that little subscript. Because what this is basically saying is, okay, we know that we have, moles of this and we have moles of that, but how many exactly do we have of nitrogen for this entire compound? So here, what we would do is, again, we would always start with what we're given first. So we're given 3.66 moles of this N2F4. And now again, I want to get rid of the N2F4. So what would I put on the top and then what would I put on the bottom?
Moles on the bottom.
And then which moles would it be that goes on the bottom?
The N, no,
N2F4.
two.
Or
Yeah, because you want to make sure that compound cancels out. And now we can put this 2 moles
on the top.
on the top. And so that's how those would work. So, but there's a little bit of a difference when we start doing the stoichiometry. So we'll put a pin in that for right now. But this is how we would do it in a situation where it asks for the nitrogen atoms for this particular molecule.
How did you know it had 2 nitrogen atoms? How did you know that?
Because of the subscript. So you see how it's the N2F4? That tells us that we have 2.
Oh, 2,
atoms of
because the
nitrogen.
N2, okay.
Yeah.
Oh,
And then- So
sorry.
same thing if it was for fluorine as well. So if it said how many moles of fluorine do you have? We have 4 moles of fluorine per 1 mole of this compound. So that's the way to kind of remember it to make a little bit more sense. And I'm sorry, I cut someone off.
No, you answered the question. That's what I was gonna ask. Yeah,
Oh, perfect. That works out well.
yeah, thanks.
I love when that happens. All right. Now, another thing that we want to keep in mind is how do we go from, let me go to number 12, moles to grams. So whenever you're dealing with moles to grams or grams to moles, now we're going to be looking at the molar mass of the compound. And where do we get the molar mass from?
Periodic table.
Periodic table.
Very good. Yeah, so that's where the periodic table would come in handy. So if you're going from moles to grams or grams to moles, we got to be able to do that molar mass. Okay, so looking at this guy here, if you had 2.48 and we said that that was in grams. And then, sorry, just one moment.
We're gonna check it all coming up at 20. Jen, talking Lions football. Go.
Okay, so now we have 2.48 grams of this NF3. And what we want to do is we want to get it to moles. So we have to go to the periodic table and we have to figure out the molar mass of NF3. So again, for you guys, when you go to use your, when you guys go to do your midterm, you'll have that periodic table in front of you. So, but for right now, again, we'll just look at the references. So here we're looking at nitrogen, and nitrogen would be 14 for that molar mass. It's the atomic mass number. So 14 plus, and then we have to go look at fluorine. And fluorine is this 18.998. So again, we would kind of just round that to 19. And because there's 3 of the fluorines, we have to multiply by 3. So this would give us our molar mass. And I'm gonna go on my phone today to get like a quick little piece. So we have 19 times 3, and then we're gonna add it to 14. So our molar mass would be 71 grams per mole. And that's how we will total up the molar mass. So again, if you want to make yourself a little reference to say molar mass, go to periodic table, total up numbers or symbols. Make yourself a little mental note so you know what you're talking about, and make it to where, okay, I know, like even if you want to show yourself an example, do like water equals 18 grams per mole. Give yourself like something to write with it. It will help you to remember what you're doing. But anyway, so we start with this 2.48 grams of NF3. What we're going to do is now we want to get to moles. So what we'll do here is we'll put the 1 mole of NF3 on top over, and did I say it was 71 grams? 71 grams of NF3. So now that cancels out, and now we have our number in moles. So when you go from grams to moles, we use that molar mass. Does this make a little bit more sense? Just kind of talking through it a little bit.
Yeah, yeah.
The more we talk about it, the easier it'll get. So the more you hear it, the more you look at it. Again, I would even suggest if you want to go back into those OWL homeworks and watch the videos or watch some of the tutoring videos, keep listening to it. It will definitely help for sure. And then was there a question by any chance?
Yes, so you just multiply the 2.48 by the 71 and that gives you the answer?
So you'll actually divide it. So it'd be 2.48 divided by 71.
How do we know when to divide and when to
Thank
multiply?
you.
So basically imagine, if you will, that if it was on the top, so because again, what we're trying to do is we're trying to cancel out those numbers. So like for this NF3, the grams, because we have it on the top here, we want to put it on the bottom here. So now we're dividing by it. Imagine that this little line is telling you that you're dividing it. So it looks like something like this, divided by 71. So you do 2.48 divided by 71. Does that make more sense? Versus if it was like this, let's just say 71. Now you're going to be multiplying it. But again, because it's on the bottom, because we wanted to cancel it out, then we go and divide it. Does that make a little bit more sense?
No, because we wanted to cancel the other problem out too, and we didn't have to divide.
So like, which question are you talking about?
So
The
how do
one
you know
before?
when, the one we just did before? So how do you know when to divide?
So it all depends on what's going on the top and what's going on the bottom. If your number is going on the bottom, you're dividing. If it's on the top, you'll multiply.
So Genevieve, I think what you're asking is like, how do you know when to divide it to get like moles and grams, right? So like for this question, I think that it was asking for moles.
Yeah,
This
so
one was asking for moles. So what we did was we started with 2.48 grams and we put that on the left for the starter and then multiplied it by 1 mole at the top per, well, there's 48, however many grams at the bottom per this 1 mole. So that way the 2.48 grams on the left will cancel out with the total amount of grams at the bottom of that compound. So that way you would go 2.48 times 1, because that's straight across, and then divide it by the bottom. And then that gives you the answer that you're looking for.
Thank you so much, because I was, I'm not gonna lie, I was so lost. I even hired a tutor. So
Yeah, does that make sense though?
It really do. I was totally lost.
Thank you. I was gonna say, thank you for
Thank
explaining that so perfectly. I was like, I'm just gonna let you roll with that. You're doing awesome.
So that's why I'm asking a lot of questions, y'all, because I really need it.
Well, no, like I said, ask questions now, because this is the time that everyone's on. And if you have that question, someone else has the question too. So it's always, if there's a question, make sure you ask for sure. So yeah, that's exactly it, because we're going to start with what they gave us first. And I just wrote this wrong. Because they gave us this first, we start with this. Imagine that this is like over 1. And then we do times, but because we want grams on the bottom, so again, it would be that 71 grams per 1 mole, and that 1 mole goes on the top. So it's doing 2.48 times 1 divided by 71, because that's what we got from the molar mass. So does that make more sense to everyone?
Yep.
Okay, cool. Yeah, yes. No, thank you so much. I'm so excited that that worked out. And like I said, sometimes it's the best thing is if someone else can teach it to you, A, you know that you understand it because you're teaching someone else, but also again, it's an extra set of like hearing it from a different perspective always helps for sure. So in that case, why don't you guys tell me how to do, let's do this one because I already told you guys the molar mass. So the molar mass of NF3 is 71 grams per 1 mole. So why don't we do letter B? So it says how many grams of nitrogen trifluoride, which is that NF3, are present in 3.63 moles of this compound. What would I do first?
3.63 moles.
Yep, good.
And we're gonna multiply it by the 71 grams over 1 mole.
Exactly, perfect, over 1 mole. Now, because here we want to get rid of the moles, moles are going to go on the bottom and that 71 grams goes on the top. So now again, when you see it, you're going to do 3.63
Multiplied by.
multiplied by
71. Okay.
Does that make more sense? Yay,
Yeah.
I'm so happy that that makes more sense. Because like I said, these are some of the hardest problems that you're going to do for sure. So I'm glad that that works out a little bit better. Now, I did see, and I want to just go back to the chat really quick to make sure I didn't miss something, because I think there was another one that got mentioned. Okay, so, okay, so this was a question about scientific notation and significant figures when multiplying. So perfect, I can definitely go over that. So let's go back to the significant figures and then the calculations. So when it comes to significant figures, depending on if you're multiplying or dividing or adding and subtracting, we'll do something different. Remember, a significant figure, if it is a regular integer like 1, 2, 3, because it's not a zero number, they always will count. So this would have 3 significant figures. Leading zeros never count. Captive zeros, which means it's in the middle, will count. And then trailing zeros will count if there's a decimal place somewhere in the problem. Doesn't matter where it's in, but if there's a decimal place present, then that zero counts. If there wasn't a decimal place present, then that zero wouldn't count. Now, when we add and subtract, we go by the least amount of decimal places. If you're multiplying and dividing, you go by the least amount of significant figures. So if we go to this problem here, let's just say hypothetically, again, when you look at this number here, number 6, you have 82.206 and you multiply it by 37.82. How many significant figures are here?
5.
5.
Very good. And then how many are here in this 37.82? 4. So we always go with the least amount of significant figures when we divide. So this should have how many significant figures?
4.
4 significant figures. Yep, very good. So now what's going to happen is, again, you just have to plug this into your calculator. So this is the easy part, because let me do this as I get myself stuck. Okay, so now we're going to do 82.206 times 37.82. No. 0.82. So now we get this pretty big number. And again, we want to go with 4 significant figures here. So when we look, here are 4 significant figures. Now, with rounding, if this was greater than 5 or 5 and greater, we would round that number to go up. But because it's a 0, this would just stay here. So this would be 3109, just like that.
So when
Does
you
this-
say round it up, it would be like what, 32?
So what would, yeah, so what would end up happening here is, let's just say hypothetically this was an 8. This would now change to a 0, and now this would make that 1. So now it would look like this. Something like that when we were done with it. Because when you would round up the 9, it would become 10. So it actually drops to the next number. And that's what makes it a little bit tricky on this one. So you're always going to round up. Now, let's just say hypothetically it was something easy. Like it was just, instead of it being a 9, this was an 8, it would round to a 9. But because it's 9, it rounds to a 10. So it actually afflicts this number as well. So then that becomes a 1.
So it will look like 3110.
Exactly. Yep. You got it. And then depending on if you need 4 significant figures or 3, you'd add a decimal place or you wouldn't. So if you have no decimal place, that trailing zero doesn't count. If you add a decimal place, the trailing zero does count. Now, was there a question when it came to the scientific notation for it? And then, yes, there was a question about, for this guy here, do we need to add a decimal place? We don't, because technically this zero is captive. So we don't have to put a decimal place anywhere because they only care about significant figures. But when it comes to adding and subtracting, you do care about decimal places. So a decimal place would have to be present. But for multiplication and division, you don't have to worry about it. Now, how do you guys feel with, like, so do you guys feel comfortable with significant figures, or is it more of just like when the significant figures are taking place?
Kind of both for me. It's just that every time I put in my answer for that specific section, it always to me I was wrong, even though I had like the 4 significant figures. I made sure that there weren't like any leading or, the zeros that shouldn't count. I made sure that they didn't count and all that. It was just a little confusing on like how I was really supposed to do it.
So rule of thumb, what I would do is, let me pull this up really quick. When you do go to do the calculations, because it was at number 6, like this one for the calculation question that kept marking you wrong.
Yeah.
So what I would do is I would plug this straight into your calculator just as is, and then do the rounding. Because sometimes if you round it too early, then that can happen. And then also sometimes it's just picky as well. Now, again, the biggest thing is to also look for those trailing zeros. And then again, if they throw a decimal place in there, usually that's the one that always gets everyone tripped up without seeing it. If you end up finding it, just send it to me and I'll kind of show you, because I can then show you like step by step on that problem, what it's supposed to look like. But if it comes up again, just send me a picture and I'll kind of run it through with you as well. Now, like again, for this letter B, because this is an adding one, again, we go with the least amount of decimal places. So how many decimal places should we go with? This guy has 3 behind it. This guy has 2 behind it.
2.
Yeah, exactly. 2 decimal places. Then we go to plug that into our calculator.
It's
it-
120.02.
120.02.
Yep.
Perfect. All right, so let's see why it's saying that. So let me do 82.206 plus 37.82. Oh, so see what is going on here is, okay, so you have 20.02, but we don't just care about the 2, we have to care about the 6. What does this 6 tell us that we have to do then? Because it's greater than 5.
You have to
Oh, we have to round.
Round
so it'll
up.
be 0.03.
3.
Very good.
Oh,
Now it works.
okay.
Yeah. And that's why I like to work with these problems with you guys, because sometimes if you see it, then you're like, oh, okay. Because otherwise you sit there for an hour and you're like, why did I do this wrong?
I
What?
see now. Okay.
Yeah, that might be it. So always, and see, that's why we practice. Practice makes perfect, because
I
then
was
when you're
tired that night.
it's okay. That's honestly, it's not easy. And again, it's the practicing. And then if you see it this way, you can go, oh, okay, that's what I gotta do. All right. Are there any other problems from like OWL 1 that you're like, okay, this, I don't understand at all?
Well, I have a question. Why
Yeah.
is it that, okay, you know how some of them have 3 problems in there? So if you get the first 2 right and you may not get the 3rd one right, it make you start all over, all 3 problems over.
It shouldn't though. It should just give you, so with the requirement, it should just make you do 2 of them. So if you get, so like for instance, because this one only has 2, you have to get all 2 of them correct. But some of them that have 3, you only have to answer 3 of them. Once you answer the 3, you get the point and you're good to go.
Okay, no, well, maybe I'm explaining it wrong. So, okay, after 3 questions, if I get the first 2 right, then I'm on the 3rd problem, right? I get that wrong. In order for me to do that problem over, all 3 of them start over.
But
So-
you don't have to.
Yeah, I had that
Yeah.
problem too.
Yeah, because
So
that
I personally
only-
wouldn't worry about it. If you get 2 of them right, I wouldn't worry about if that
Starting
other
over.
one is wrong or not, because you technically got your point for that little section.
Oh, really?
Yeah.
Yeah.
So
Had to
don't
You
add
just
do
that.
required to
it.
do two.
I
One
didn't
You
know
only
touching
that.
my
required
M, I
it
move
says
right along.
two.
Yeah.
I'm glad I asked because I've been doing all
Required
three of like
for 1 point.
Yeah.
over, and they all start over.
Yeah,
As soon
no,
as you
okay,
see
I'm
the
glad.
M, that means you mastered it, so you don't have to do the third question.
Yeah.
Oh,
Yeah,
oh, wow.
so Genevieve, yes, just get your two. If you get one wrong, whoops, look at it, make sure you know why, move on to the next one. Because if you
Yep.
hit retry entire group, you have to do it all over again, and you don't want to do it over again. So yeah, you two went out. Once you get your two, don't repeat it. Don't repeat it over unless you want to practice. Now, once you've submitted and you've finished the assignment, you can go back in and practice. But don't, yeah, if you get two, you're good, you got your point. That's what's considered required, is that you had to just get two correct, continue on to the next problem. It'll definitely make life a little bit easier. So hopefully you guys then that can make you guys go a little quicker too to go through these. Otherwise, yeah, you might be here for a while. Yes, if you like, because again, we all make mistakes. Even like, again, when I go to rate it, you'll see that there's a little blooper that I may do because it's one piece. It's okay to get one wrong. We just want to make sure that you have the majority of them correct and you're understanding that you're on the right track. But yeah, no, unless you're practicing, just get your points, submit, call it good. That'll definitely save you some time. All right, now any other questions from L1 while I have you guys here?
I have a question. This is Francois. I was like 10 minutes late, so I'm not sure. Did you already go over the density ones? If so, I can just watch the recording.
No, I was gonna say I didn't. So that's a good one for me to go through. So for density, so density is actually not too terrible. And because density, the equation is density equals mass over volume. As you're going to see, the mass is going to be in grams and the volume is either going to be in like milliliters or liters, depending on the conversion. Now, I have a trick way of doing this. So when it comes to density, let me do this. I always make a little cheat sheet for myself. So when I used to tutor, I had students that hated algebra. So it was easier to show them this way. You put density on the top. I'm sorry. You put density on the side here, and then you put mass over volume. So mass goes on the top, and then you have density on the side, and then you have volume. If you're trying to solve for density, density is mass over volume. If you're trying to solve for mass, it's density times the volume. And if you're trying to solve for volume, it's mass divided by the density. So you just stick your finger over, or you just kind of remove what you're looking for, and then you can just plug in the problems. Does that make a little bit more sense to kind of help save time for the density problems?
Yes. Can you look at the second one or the third one? I think I did that first one, but I'm trying to
No worries. So that's like this one here.
Let me see.
Because we may have a little bit of a different problem, but if as long as you see maybe what the problem is, we can kind of show an idea.
Yes, that's the problem.
Okay, cool. So here, what they did is they gave you the density. So these numbers here are telling you the density. They also tell you that you have 17.6 grams. And the question says, use the unit analysis to calculate the volume. So we have the mass is the 17.6 grams. We have the density for aluminum, and it's 2.72 grams per milliliter. What we don't have is the volume. So using our little trick here, density is mass over volume. Oops, I did it wrong again. My brain does not want to work. Density is mass over volume. We want to kind of circle out volume, and we're going to do that volume equals the mass over the density. Now, it's easier to just write this on a piece of paper. OWL makes this significantly harder because they just can. So what we're looking at here is that we want to do that we have our mass, and then basically what it's trying to make us do is put in ones at the top over our density. So it's showing you the mass in grams, and then we are dividing by the density on the bottom. They have this written very poorly. So all we have to do here is we have to put in for aluminum. So it's this 2.72. And then what we're doing is we're putting grams on the bottom over the milliliters. Because what would end up happening is if you divided grams over grams per milliliter, the milliliters would go on top and the grams would cancel out. That's what makes this problem suck, is this little piece here. It's a pain in the butt, but that's how they want you to write it. But basically what you're saying is volume equals the mass over the density. And that's what it's trying to get us to write. Then when we do 17.6 divided by 2.72, we get this 6.47 milliliters. Does that make a little bit more sense for those density pieces of how they want you to write it? Because this is confusing, and it's not confusing because the problem's hard. It's because of how they have this little box piece written. Does this kind of make sense?
Yes, it makes a little bit more sense. I'm gonna look at the recorded after class so I can thoroughly go through everything.
No
But yes,
problem.
That'll help me. Thank you.
Okay, for sure. And then let's do one more, because like I said, it's not actually the density problem that's hard. It's this, how they have this bottom piece written. So same thing, we want to calculate now the mass. So we don't know what the mass is. We know that we have the volume because it tells us 18.5 milliliters of copper. And we know density of copper because we can just get it from this little substance sheet here. So copper is 8.94 grams per milliliter. Now again, using our little triangle, density is mass over volume. If you stick your thumb over the mass, mass equals density times the volume. And so here what they did is they gave you the volume, and now we're multiplying by the density. So now we put that on the top, this 8.94 grams. The milliliters goes on the bottom, and this will just be a 1. It's like a placeholder, if you will. So then we do 18.5, and we're going to multiply that by 8.94. We want 3 significant figures. So this would just be 165 for our grams. And then we can submit our answer and we're good to go. So like I said, it's not the problems that are hard. It's this weird setup that they have. And luckily you don't have to deal with that for your midterm because it will be multiple choice. So you don't have these little boxes of craziness to try to follow out. But I want to make sure you know how to do the problem. So.
Okay. Yeah. So how did you know that it's supposed to be 3 significant numbers? That's just something you just need to know.
So, yep, when you look at this here, start with what they gave you. And because there's 3 significant figures in what they gave you, go with 3 significant figures. Yeah, whatever they give you, if just say, okay, that's 3 significant figures, that's 2, that's 4, and then just make your number the same number. Make it uniform in that way.
Okay. Well, yes, today was really very informative because I was ready to cry and pull all my hair out. I was at work, like chemistry is not my friend right now. I hate chemistry.
Well, don't hate it. As I say, it's difficult and it's hard, but I promise you guys will like it towards the end. Now, again, if anyone came in late, a couple things, just make sure you sign your name into the comments so that way I can mark you on. And then also, I'm going to change the OWL homework. So again, it's due at the end of the semester, but you guys will just work on it week to week. So instead of it being where it's all due at this time and you guys are freaking out about, you know, like I have one problem that I don't have done, and I'm going to get 10% deduction. We're just going to move it to where the due dates are all out at the end to kind of help alleviate some of that stress for sure. But all right, cool. All right, let's move on to OWL 2. So for OWL 2, are there any questions? Because I know OWL 2 was definitely a you know what kicker. I'm not going to say the word. I'm worded, but you know what I'm thinking.
I had a lot of trouble because I actually texted you.
Yeah.
I had still a lot of trouble with 14 and 15, like
Okay.
one for each of those.
All right, cool. Let me pull that up. Start assignment now. Are these still the stoichiometry ones?
Yeah, like towards the end.
Those
Yeah.
ones were ridiculous.
I was so confused. I just gave up.
I
Well,
did.
don't give up. It's like you can always send me a
I
message.
did see an answer and I said, I'm submitting it. It was making my brain hurt.
Okay, so let's go through these then. So let me just do one from 14 and one from 15, and we'll kind of go step by step. So stoichiometry runs a certain way. And the way you know that you're doing a stoichiometry problem is, like, for instance, here, they say, according to the following reaction, A, if they give you a balanced equation, already kind of know in your head, oh crap, I'm going to do a stoichiometry problem. If it's set up kind of like this. So there's a balanced equation, the nice little hint. But also what it'll say is, like, for instance, how many grams of calcium carbonate are necessary to form 0.48 moles of carbon dioxide. Because you don't have the same formula, you don't have the same piece, you know you're going to do a stoichiometry problem. Because if this was how many grams to moles of calcium carbonate and they were both calcium carbonate, you're just doing a conversion from moles to grams. But because here we're going from one substance to a completely different substance, stoichiometry time. So how stoichiometry is set up is grams of A, and I always tell you, I always think A is what they gave me. A is what I know. And so, like, for instance, we know that we have this 4.8 moles of carbon dioxide. That would be my grams of A. Or that would be my A, I should say. 2 moles of A to moles of B, and B is what we're looking for. We don't know this one yet, but we're going to find out. To grams of B. Now, sometimes we can bypass a little bit. So for instance, because this guy is asking us to go from grams of B, so that's like where we're trying to hit our destination to, but we're starting with 4.89 moles of carbon dioxide. We're going to start here instead. So we can actually skip this step just to make life a little bit easier. So what we're going to do is we're going to start with this 0.489 moles of carbon dioxide, CO2. And now, because I have moles of what I know, I want to get to moles of B, what I'm looking for. And what they asked me for is calcium carbonate. So that's this guy here. So when I go from moles of A to moles of B, I have to use my balanced equation. And what I do with this balanced equation is I do where I want to find out the coefficient out in front to get my moles of one to moles of the other. Now, in this situation, it's pretty easy. I have 1 mole of carbon dioxide. The reason I know I have 1 mole of carbon dioxide is because there's not a coefficient out in front. So I will put that on the bottom because I want to get rid of carbon dioxide. And I want to get to moles of calcium carbonate. So how many moles of calcium carbonate do I have? How many coefficients do I have out in front?
None. So technically 1, right?
1. Very good. So that's 1 mole calcium carbonate. And now I want to go from moles to grams of my calcium carbonate. So again, how do I go from grams to moles to grams? What do I have to use?
So we need the molar mass from the periodic table.
Very good. Molar mass from the periodic table. So we would get our grams of CaCO3. And again, we want that on top because it's asking us to look for grams over 1 mole of this calcium carbonate. The moles would cancel out. And now I'm going to use my numbers and say, okay, I have 4.89 times 1 times whatever this grams is. And it would just be dividing by 1, so we don't do that. So we would just multiply it out and find out what we're looking for.
So this part of it I get. And I think every single time when I get to like the grams part of it, I think in my brain I do, so I have 1 molecule of calcium, and then because I have 3 molecules of technically like CO3, I do I do CO times 3.
Okay, so here what you want to do is, so you're saying that just like the molar mass gets funny when you go to type in the
Yeah,
number?
it's just my molar mass. So I think I multiply oxygen 3 times, and I don't know if I'm supposed to do that or not.
You will do that for the molar mass. So you'll look at calcium and say, okay, I have 1 calcium, so I'm going to total that up in my molar mass.
Okay.
I have 1 carbon, so I'll total that up in my molar mass.
And
And now I have, and 3 oxygen. So you're taking account all of those pieces in the molar mass versus when we're looking at moles, we just pull the coefficient from front. We just care about it there.
So then what if it was a 2 up there? Would I have 2 calciums, 2 oxygens, 2?
Not for necessarily the molar mass. The molar mass, you just look at the actual compound itself.
Okay.
Because what's happening is in this step here, they're taking into account that too.
Okay.
So you don't have to then write it twice.
Okay.
So for that, just whenever you get to the grams, just look at the whole compound. Don't look at the coefficient.
Okay.
But when you do the moles, look at the coefficient.
Okay.
Yes, it's a super fun. Whoever came up with this is crazy. That's the best way to describe it. Someone spent way too much time to figure this out.
Yeah,
But
they ghetto for sure.
they figured it, they had a lot of time. They're, some chemists and scientists are a little bit more inquisitive than I am, I guess. They're a little bit more than I am. All right, now for this one here, it says, according to the following reaction, how many grams of zinc hydroxide are required to complete a reaction of 25.8 grams of this sulfuric acid? So again, here you're going from grams to grams. So you got to go grams of A, which is what you're given, to moles of A, to moles of B, 2 grams of B. So in this situation, we start with our 25.8 grams of sulfuric acid, and that's going to be this guy here. We're actually going to talk about acids tonight, H2SO4. And now I want to get to moles of H2SO4. So when I go from grams to moles, what do I have to use here? What would I get from grams to moles? Or what would I use from the periodic table?
So you want the molar mass of H2SO4?
Exactly. So
However many moles.
yeah, over how many moles. So I'm just going to put grams of H2SO4. And again, I'm just going to put periodic table. So you total it up from the periodic table.
Wait, isn't that going to go on the bottom?
Yes, it is. Dang it. Thank you. And so we're going to do, yes, it goes on the bottom. So we do grams of H2SO4. And again, I'm just going to put periodic table for right now, over 1 mole. So now the grams cancel out. And now we have moles of H2SO4. Times, and now we're going to go from moles of A to moles of B. Moles of B is what we want to find out. So we want to now know for zinc hydroxide, that's this guy here. So we want to get this guy. So now to go from moles of A to moles of B, we use the coefficients out in front from that balanced equation. So how many moles of H2SO4 do I have?
1.
1 mole. Very good. And then how many moles of this zinc hydroxide do I have?
1.
Yep, very good.
That makes sense.
Good. See, it will get easier. The more and more you see it, the light bulb will click. It's just the first, I'm going to say 20 times you look at it, you're going to be like, what in the world is this? And I promise you, that's what it is like. It is the weirdest thing when it comes to these stoichiometry problems, but they will get easier because it's the same rhythm, the same thing that you'll do over and over, kind of like clockwork, like a recipe. All right, and now we have moles of this zinc hydroxide, but we want to get to grams. So how do we go from moles to grams?
So then we would find the grams of zinc hydroxide over 1 mole.
Yeah, very good. So we get that from the periodic table over 1 mole. Very good. And that cancels out. And then we can just go calculate. So it would be 25.8 grams times whatever the grams is of zinc hydroxide. And we would divide by the grams of H2SO4.
And now when I would do the molar mass of that, I would take 1 of zinc
Yeah.
and then O2 as a whole and multiply that by 2, right?
So here what will happen, because OH technically is oxygen and hydrogen, it'll be oxygen times 2 and
Hydrogen.
hydrogen times 2. Yeah.
Okay.
When you go to type it in for the molar mass.
That's where my brain kept like disconnecting.
Believe it or not, mine actually did too. And I remember, I can actually tell you the problem I got wrong on my chemistry test many years ago. It was 2Cl2. And same thing, because Cl2, I was like, okay, 35.5 times 2, but there was 2 out front, so I times it by 2. And then no, because the moles to moles accounted for that. I can still tell you the problem. That's what makes it so funny that, you know, it's like you always remember the ones you got wrong. And yeah, to this day, I still remember that. So
This is
I was stuck.
definitely going to be that one that I got wrong. I'm not even going to lie to you.
Yeah, it's always, yeah, those are always the fun ones. But all right, are there any other ones from, oh, okay, so actually, I think Ashley mentioned the electronegativity questions. So when you have this guy here, when we talk about electronegativity, as you move across the periodic table, the electronegativity increases. So for instance, fluorine is the most electronegative you can be. But as you move down the periodic table, the electronegativity decreases. So the least would be francium. So what they want you to do is they want you to say, okay, let's put these in order of increasing electronegativity. And they give you the numbers to look at. So we have lithium, we have potassium, sodium, and rubidium. So looking at this guy here, we want to go to increasing electronegativity. So again, as you move down the periodic table, the electronegativity decreases. So which one is the least electronegative out of these 4? Rubidium, very good. And then what would be the next least, if you will? Potassium, very good. And then it would be sodium.
Then lithium.
And then lithium, very good. So if it gives you a hard time on these, screenshot them to me because I will yell at Al personally. But that's how those ones are going to work. Now let's try a different one really quick. So again, this is increasing electronegativity as we go across. As we work our way down, it's going to decrease. So we're going to do rubidium. We have tin, which is SN. Where are you at?
Under.
Oh, here it is. I'm like, where's SN? All right, we have the indium, which is this guy here, and then we have strontium, which is this SR. Okay, so which one would be the least and which one's going to be the highest, if you will? So which one's the least?
Rubidium.
Very good. And then which one would be the highest?
SN, strontium.
So strontium would be the next, and then we'd have indium, and then tin would be the increasing. Do those make sense?
Wait, which one is 10? SN?
SN right here.
That's what I was looking at.
Yep. It's funny when they don't necessarily go with the right order, because like, for instance, like there is an ST, but it's not strontium, it's for something else. So they get creative with their symbols a little bit. But does this make a little bit more sense for the electronegativity of how it should work?
Mm-hmm.
Okay, good. So if it gives you the wrong answer, screenshot it over to me and I'll make sure you get the points. I'll go in and just manually change it for you.
Can you go over question number 1? I struggled with it.
Yes, thank you.
Yeah. All right. So the Lewis data
Oh yeah, I forgot about that one.
I think these are so much fun, but I will explain why they're fun to me. All right, get out the periodic table really quickly when we go to look at this here. So depending on what group you are in, this will tell you how many valence electrons there are. So if you're in group 1A, they have 1 valence electron. If you're in 2A, they have 2 valence electrons. Skip the transition metals, they're difficult and confusing. Move to 3A, 3 valence electrons, 4 valence electrons, 5, 6, 7. And then technically 8A, these are all of our noble gases. So what the noble gases do is it means that they have their outermost shell complete, because what valence electrons are looking at is how many outer electrons do we have that are sort of left over, if you will. And because they're left over, they are extremely, extremely unstable. So for instance, I've taught at Baker for 8 years now. Many years ago, I damn near lost my job because if you put pure sodium in water, it explodes. Now, I used to do this every year for a school, like we'd always have like a 6th grade presentation come in, and every year I would put a little chunk of pure sodium in water because pure sodium, again, is so reactive. We actually have to leave it in kerosene. So you put a little piece, you add just a tiny bit of water and it whistles and goes, whoosh. So the kids all think it's cool. One of the days I was a little tired, wasn't thinking it through, put a bigger piece of sodium in there, put it in a glass container, and threw water in it. It exploded all over the 6th grade class. It was all over me. And unfortunately, sodium is very reactive. So it was like reacting to the makeup I had on. It was reacting to the air. So now we're making sodium hydroxide in the air. It was all over the computer. It blew out the light. And I had every mother screaming at me along with, a bunch of 6th grade class. And I was just told to never touch the sodium again. So it's now still permanently locked up and I am not allowed to get into it. It's a special key that basically is the not Alyssa key. But it was many fun for many years. And I have a video if you guys are interested. I'll actually show you a little video of it. It goes crazy. I may have also taken a little piece home to take for fireworks and threw it in a lake. Super fun, awesome day, probably killed some fish, but super cool. They're super reactive. But because of that, it's because of those valence electrons. So the goal is that all of these other guys want to be like these guys here, the noble gas, because the noble gases are completely stable. They have the correct amount of valence electrons in their outermost shells. These other guys don't. So they're either going to give up electrons or they're going to take electrons. And because they give and take electrons, they'll either gain a positive or a negative charge. So with this question here, if you go to these guys, and I'll kind of run through a couple of them. This is the Lewis dot structure. So this X means absolutely nothing right now. It means that we don't know what the symbol is. So that's its nice way of kind of making a something cute. Like it's just like unknown. But we know that it has 1 valence electron. So because of that, what group is it in? Is it in 1A, 2A, 3A?
1A.
Very good, 1A. Now, it has 1 valence electron. So let's just say hypothetically, in its outermost shell, it has 1. It wants to technically have 8 in that outermost shell. So does it pick up 7 more, or does it just give away that 1 extra electron? What would it do? What would be easier, to grab 7 and make this complete, or just to give away this 1 electron?
Give away 1.
Yeah, give away 1 electron. So because it gives away an electron, now what happens is you have more protons than you do electrons. So it actually gains a positive 1 charge. Now, what this says then is if X was in period 5, so we have to go to the references and we got to go to the periodic table. So if we were in period 5, it kind of already gives us the hint that this is rubidium because it's 1A, 5, rubidium would be the guy here. But what it says is the ion formed has the same electron configuration as the noble gas. What it's saying is if we took away that 1 electron, it would be closest to krypton because again, krypton is going to be balanced. It's going to have those complete shells filled. So again, it doesn't become krypton, but because it lost that extra electron, now it's acting like krypton. So that's why it's saying it in that format. And oops, I lost my owl. Where's my owl?
So if it's -1, we always go to the one behind it.
So if it's a positive one, because you lost that electron, go to the one behind it for sure.
Okay.
If it's a negative number, so like for instance, fluorine wants to pick up an extra electron. So it's going to be the one next to it. So if it's a negative number, like if it's -1, you'll move it that way. So let me show you really quickly.
So when they move it, like the one next to it, it's like technically the noble gas that's in the same period as it, right?
Yeah, so let me pull this up really quick. So like, for instance, with rubidium, because it's in this group 5, if you will, or it's in this period 5,
Right.
we're gonna move behind it. But let's just say hypothetically, we were looking at iodine. Iodine would pick up an extra electron, so it'd be like xenon, this Xe. Does that make sense?
So then if we're looking at rubidium and it takes an extra electron,
It's gonna remove an electron because it has one additional, so it wants to get rid of it.
oh, I got you. Okay.
So because it's getting rid of it, we're gonna go with krypton.
So iodine would need an extra one. right?
Exactly. Iodine would need an extra one
So
to
we
be.
go to the one in front of it.
So you would go to the one, so like for instance, iodine would have xenon next to it. So it would go to the one next to it, if you will.
Okay.
So let me pull this back up because now I got a different question. Okay, so then we said this is 1A, positive 1 charge. The no gas will be krypton.
Wait, so I thought it would be -1 because it's giving away 1.
Because it's giving away an extra electron, it's gaining a positive charge. Let me explain why really quickly. So let's just say hypothetically you had, let's make it an easy one. Let's do lithium because lithium has an atomic number 3. That means it has 3 protons and then 3 electrons. So that first shell, you got your little nucleus, protons and neutrons are inside. That first shell, we put 2. That second shell, we just have 1. It doesn't like the fact that it just has 1. So it wants to get rid of this electron. So because when it does that, it still has 3 protons.
So it's lending technically.
Yeah.
Okay.
And now because it has 2 electrons, because it got rid of that, now protons have a positive 3 charge. This guy has a -2 charge. They overall have a charge of +1. So because it got rid of an electron, it gained a positive charge. Does that make more sense here?
Mm-hmm.
Okay,
3
good.
-2 is a +1.
Yeah, it's a positive 1. So lithium now would look like this,
I
+1.
didn't realize I have one.
Well, and this is why it makes it so much easier, because now what you can then say is, okay, now I know that this is lithium +1. Same thing when we were looking at that rubidium. Rubidium, again, because of its outer shell, it's at 1. It wants to get rid of it. So now it gains a +1 charge. That's +1. There is a school of thought too. So let me actually, again, something to write on your little periodic table as well. Let me pull this up. If you're not sure what charge it's going to be, I'm going to show you an easy way to remember it. If you're in group 1A, they have a +1 charge. If you're in group 2A, it has a +2 charge. Skip the transition metals for right now. If you're in 3A, it's a +3 charge. And now it starts to move a little bit different. These guys are a little bit tricky in how they're written. So I now work my opposite way. And I say, okay, if it's in group 7A, it's a -1. If it's in group 6A, it's a -2. If it's in group 5A, it's a -3. These guys kind of vary, so I kind of leave these guys out. But if you need to write this down on your periodic table, write this down. Group 1A is a +1 charge. Group 2A is a +2. Group 7A, -1. 6A, -2. 5A, -3. And then 3A is a +3 charge. Like I said, carbon and these guys in the middle get a little bit funny, so they're not quite the ones that we would use. but this will help you to remember them of which ones are which. Why does this keep going out? I don't understand. Okay. So again, so then what we do here is we'd write just the ion channel, or we'd write the ion symbol, and it's going to keep kicking me out. It's going to drive me totally bonkers here. I think it's because I have this open. Sorry. It's getting me, I'm getting frustrated with this stupid thing because it keeps just locking me out. Okay, so 1A.
Oh, now we're back.
One charge.
Okay.
Krypton. And then this is the rubidium. And then we just put +1 for the symbol. Because now we have rubidium for our ion. And then because it's an ion, it has a +1 charge. Does that make a little bit more sense?
So there were some on there that, like, when I tried to do this, when I tried to put Krypton, it said that it wanted it like the actual 1s to that thing. It was weird.
Really? I
Yeah,
wonder
I kept getting it wrong. Though that was actually the one that I just said, forget it.
Okay, really? And it was for number 1 that it did it?
Mm-hmm.
All right, let me keep refreshing and see if I get a different one.
Because they all, like, it all looked exactly like that. Like the problem would set up like that and everything. But then when it came to like the second part, like if X is in period, blah, 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 and it has the same electron configuration as the gas.
Yeah, you're just writing what the noble gas is.
Yeah, and I did that for a lot of them. And it was telling me that it marked it wrong.
Were you writing out the full like 1s2, 2s2, or were you just writing the noble gas? So you would just,
I just wrote it as the noble gas. And then the symbol for the actual ion. So like if it had a positive charge or a negative charge, like I would do that, but it would mark the part up there with the noble gas wrong.
Huh. So let's see. Okay. Well, I'll have to see if you screenshot me a picture, I'll see why it's doing that. But it should not do that. It should just ask you what the noble gas is.
Okay.
But let's try one more of these to make sure that this makes sense. Okay, so if we're looking at this Lewis dot structure, it's 1, 2, 3, 4, 5, 6. So we know that we have 6 valence electrons. What group would we be in here?
A4. A4.
Well,
6.
We want to do 6A.
Why
So
did
it
it go
should be
16?
Because they don't understand Roman numerals. This is 6. 16.
Okay.
I actually already sent an email out to them because right when I seen it, I was like, what in the name? No. That is not the right Roman numeral. It's not the right Roman numeral. It's because also like the 16 technically is counting those transition metals, but it should just say 6A and leave it be and not throw 16 on there because it's confusing. But so if we were to look at this according to the octet rule, and remember, if you go to your periodic table, now let me double check to make sure my periodic table is up. If I go to 6A, what's the charge going to be on a 6A?
-2.
-2, very good. So we can put charge of -2. And then it says if X was in period 4, the ion has the same electron configuration as what noble gas? So if we're in period 4, we're looking at this guy here. Now remember, it's going to gain 2 additional electrons. So now it's going to look like krypton for its noble gas because now it picked up those 2 extra electrons.
Okay.
Makes sense now.
It makes a lot more sense.
Yep, and then krypton. And then now we just have to write the ion for it. So the ion is going to be this, because we were in group 4. So we're going to be at this SE. And then, yeah, -2. Very good.
All right.
And then it should work it out. Does that make more sense looking at these guys?
A lot more sense.
No.
One more measure.
No.
No, who's saying no?
Me, no.
So
I'm lost now.
okay, let's try it again and see if this makes a little bit more sense. Okay, so let's do this one. Actually, let me get a different one. Because
I got a question.
Yeah, go ahead.
Okay, it's 6 dots here, right? Am I counting wrong? So
No,
how do you get 8?
So the idea is it wants to have 8, but it doesn't have 8.
Okay.
So that's what right now it's saying, okay, in its outermost shell, there's only 6. It wants to get to 8. So it has a
Okay.
choice. It can either get rid of all 6 or it can pick up 2 more.
Okay.
So right now, because we know that there's 6, go with the group number. So this has 6 valence electrons. What group would it be in?
A4, right? If it
It,
had
it wouldn't be 4.
6?
It's going to be 6. Yep, 6A. So that would be this guy here. And then, and like I said, if to make life easier, when you're going to look at the periodic table, go with the numbers that, again, 1A will be like a +1. This guy's a +2,
Mhm.
-1,
Got it.
-2.
Mhm.
So now, if we're looking at group 6A, what's the overall charge of this group, 6A?
Negative.
Yeah,
Two.
-2. That's what the ion would look like. So now it's going to be a little bit different than the last one, because now we're going to say, okay, the X is in period 2. So we're looking at period 2. So we're looking at oxygen here. It wants to pick up 2 additional electrons to be like this noble gas here. So what noble gas does that
Okay.
make?
Neon, right?
Yep. And now all we have to do is just write the ion and its symbol. So now we know, because we looked at that periodic table, we have oxygen, but we have it as an ion. So we want to make sure that it says, it's driving me crazy, oxygen. And then what was the charge of that oxygen?
-2.
-2. And now you're right. Little bit better.
Yeah. Okay.
If
Okay.
so go back in your owl tonight or tomorrow, whatever.
Yeah.
Practice it. If it's still not, it's driving you crazy, just text me tomorrow and be like, send this to me over, and I'll try to help you through it. They
Okay.
will get easier. It's just looking at them for sure.
Okay.
All right. Are there any other questions from owl 2 while I have you guys here? Because then we'll go work on owl 3.
Ooh.
I think we're good to go to 3.
Okay, good to go 3. All right. And if anything pops up, like I said, you can always send me a message too. Like I said, I will have that tutoring tomorrow from 6 to 7 p.m. So if you guys want to jump on it, definitely jump on it. Otherwise, I'll record it as well so you guys can watch it at your leisure. All right, let's go to 3 then.
Oh, sorry, Professor, you said there's going to be another one on Thursday too?
Yep. So Tuesday, Thursday, 6 to 7 right now. Starting next week, Thursdays are going to be a little rough, but I'll make another tutoring day.
No, I have class on Thursday. I'm not going to be able to attend.
Oh, so yeah, I will record the lecture. If something pops up or there's a one question that you can always just send it to me and say, hey, can you go over this in the tutoring, and I'll record it.
Okay.
Like that's just gonna make it the easiest way. But normally, so this Thursday I have free time. Starting next Thursday, my son has football, so I will be out for Thursdays, but I'll still have Tuesdays available, and I'll probably either just make Tuesdays longer or I'll figure something out to do something a little bit different. All right, so now we're gonna go into module 3. So module 3 is going to be about different types of basically mixing solutions. So what we're going to start thinking about is if you mix things together, especially when it comes to water, what are our solutions going to look like? Now, what happens here is they're going to be asking us for different types of solutions, and they want us to know whether it's a solute or a solvent. So when you put a solute and a solvent together, it creates a solution. Now, technically, when we think of like a solute and a solvent, we think of what's being dissolved and what's doing the dissolving. In chemistry, we use a different approach. The guy that is the smaller quantity is the solute. So the smaller amount, smaller quantity is the solute. The guy that's the larger quantity is the solvent. So we use a little bit of a different approach to this guy. So a solute is smaller, solvent is larger. So going off of the owl, it says you have a sample of water with a mass of 1,000 grams, and it's saturated with 2.96 grams of hydrogen sulfide gas at 25 degrees Celsius. From this aqueous solution, water would be what? Would that be the solvent or would it be the solute?
Solvent.
It's a solvent, very good, because it's the larger quantity. And the hydrogen sulfide would be the
Solute.
solute, very good. So that one makes sense. And typically, water is going to be the solvent. That's not always true. That's why we go with larger quantity and smaller quantity. All right, for question 2,
Go back
we
to
have
that.
I'm sorry, go ahead.
Why is that? Why is the water big? Can you go back to the other one?
Yep. So the reason that water was the solvent is because the mass was greater of this guy. It was the larger quantity. The solute was the smaller number, and that would be the hydrogen sulfide gas.
Never mind. I was looking at the 2.96 grams.
Yeah, that's the smaller number. And then for water, it'd be the 1,000.
Got it.
So for next one, a homogeneous mixture is made by dissolving 8 grams of this ammonium nitrate in 1,000 grams of water. This would be an example of what kind of solution. So they want us to know, is this going to be a liquid, solute, or gas solution? So, and if you remember what homogeneous means, do you guys remember when we talked about homogeneous mixture, what that meant?
2 different.
Yeah, so it's 2 different, but can we clearly see them, or can we easily tell the difference between the 2, or can we not tell the difference?
You can.
You can't tell the difference because remember, homo is same. Hetero would be that we can tell differences. Homogeneous, it's all mixed together and we can't tell the difference between them. So if you had 100 grams of water and you mixed it with this 8 grams of ammonium nitrate, do you think that would be a solid solution, a liquid, or a gas? Think about the liquid. And then it says, in the mixture, would water be the higher quantity or the smaller quantity?
Water.
Yep, it's the higher quantity. So is it the solute or the solvent?
The solvent.
Very good. And then the ammonium nitrate would be the
Solvent.
solute. Yep. I'm sorry, you have a question? I missed it. I want to make sure I didn't cut anyone off. Okay, so that's what they're looking for here. The water is the larger quantity, so it's the solvent. The 8 grams of the ammonium nitrate is the smaller quantity, so that would be the solute. And when you put them together, it's a solution. Now, again, in a liquid solution, you have a solvent that, again, is dissolving or mixing that solute, and that's how we get that number there. Now, let's just try to do this again, same idea. According to the usual practice, we have 862 milliliters of methyl alcohol, which is methanol. If you were to drink methanol, even like a teaspoon of it, it would make you go blind. If you were to drink a great deal of it, it would kill you. So this is not what we drink. Ethanol is what we drink. Methanol is actually very deadly. But if you had 862 milliliters of methyl alcohol and only 14 milliliters of water, water would be what? Is it the solute or the solvent?
The solute.
Solute, because it's the smaller quantity. Very good. So most of the time water is the solvent, but in this circumstance, again, because it's the smaller quantity, it's the solute. All right, next thing that we want to do is we want to think about solubility. So again, when you deal with a solute, it's the smaller component. The solvent is the larger component. And when you put them together, they make a solution. Now, when you talk about your solution, it could be highly concentrated or it could be dilute. Think about it from this perspective here. So let me stop my share really quick, and I'm going to write on a screen really quick. All right, so let's just say hypothetically, you made a concoction of lemonade. My son is notorious for this. So you have a lemonade stand and you put in mostly lemon and then just this little bit of water. Would that be a concentrated solution or would that be a dilute solution? So all of this is lemonade. And then you have this very little amount of water. Would that be a dilute solution or a concentrated solution?
Concentrated.
Yeah, it'd be really concentrated. On the flip side, like I said, because I have a 4-year-old, this is usually how lemonade is made. It is all water and then this little bit of lemonade when he makes his lemonade stand. So would this be a dilute concentration or a concentrated solution?
Dilute.
Dilute. So depending on our circumstances, we can either have a dilute solution or a concentrated solution. And then finally, we can look at solubility. And what we're looking at here when it comes to being soluble is how much is the solute going to dissolve in a given temperature that's considered to be what we call saturated. Or that it's going to actually be able to become a solute and be mixed in a solvent at a given temperature. Now, with it being said, it can be saturated, unsaturated, or supersaturated. If a solution has the same solubility limit for a given temperature, it's saturated. A solution that has lower solubility than the limit for the temperature is unsaturated, and one that has this greater solubility for a given temperature is considered to be supersaturated. So you can have saturated, unsaturated, and supersaturated. And then we deal with the term miscible and immiscible. If two liquids can dissolve each other in this equal component, we call it miscible. If they're insoluble in each other, it's called immiscible. And then we can also have a partial miscible. So let's just get an idea for it. If it said the liquid, acetic acid, and water dissolve in each other in all proportions, would that be miscible, immiscible, or partially miscible?
Miscible.
Miscible, exactly, because they're going to dissolve in equal ratios to each other. All right, looking here, the solubility of calcium hydroxide is 0.93 grams per liter. If a calcium hydroxide solution had a concentration of 1.1 grams per liter, it would said to be what? Would it be saturated, unsaturated, or supersaturated? And the idea is that with saturated, again, it's going to be able to completely dissolve at a given temperature and time. If it does less than that, it's considered to be unsaturated. And if it can go past that, it's supersaturated. So what would we get for here? We had a solubility of this. And again, when we put it in this solution per, what would we end up getting here?
Wouldn't it be supersaturated?
Very good. So exactly the way it kind of makes sense. If you look at that 0.93 grams, and if it just was 0.93 grams, it would be saturated. If it was less than 0.93 grams, it would be lower than that solubility limit. So that would be unsaturated. But because this number is over 0.93 grams, it's supersaturated. So depending on what you're looking at, you want to know if it's the same number, higher or lower. And again, I would write yourself a little note when you go to write this, on your little study guide cheat sheet. Again, just make sure to make the numbers where you would know supersaturated, saturated, or unsaturated. All right. And then finally, if we were to look at this guy here, one's 0.930, this guy's 0.930. Would that be saturated, supersaturated, or unsaturated?
Saturated.
Very good. Awesome. Okay. The next guy is going to be a little bit tricky. So this is another one that we're going to work on that is an equation. So again, this is something that you'll want to have on that reference sheet. Now, I believe molarity is on your reference sheet. I'm going to double check though, just to make sure I am telling you correctly. I believe it is. Look. If you look at your reference sheet, we do have molarity on there. But again, you might want to make yourself little notes as well, just to make sure that this makes sense when you go to practice with it. All right, so what molarity is looking at is the moles of a solution over the liters of a solution. And so again, when we go to write this, we always want it to be in moles per liters. Now, a lot of times what they do for these questions is sometimes they'll just straight up ask you what's the molarity and they'll give you the numbers. But sometimes they can give you grams, sometimes they'll give you milliliters, and we have to do some conversions. So here it says a student weighs 1.15 grams of this NH4Cl and transfers it to 100 milliliter flask. And then adds enough water to dissolve it, and then adds water to the 100 milliliters at the tick-tock mark. Okay, so what this is telling us is that we have our mass in grams and we have 100 milliliters of our volume here. All right, let me do this real quick. Okay, so we want to figure out molarity. Now, molarity is moles per liters. So unfortunately, we don't have moles and we don't have liters, but we can get there. We can convert grams to moles and we can convert milliliters to liters pretty quickly. If I wanted to convert milliliters to liters, what would I do here? If I wanted to convert this, how would I convert 100 milliliters to liters?
Multiply by 1,000.
Be careful. So think about that. King Henry died unexpectedly drinking chocolate milk. If we're going from millis to our unit, we're going to move it 1, 2, 3 places to the left. 1, 2, 3 places to the left. So this is 0.1 liters. So don't forget this little cheat sheet to remember what way you're going. So we're actually dividing by 1,000 milliliters. And then here we have grams, but we want to get it to moles. What way do we go from grams to moles? Think about what we just talked about. How do you go from grams to moles? What would we use from the periodic table?
The mass number?
Yeah, the molar mass. So we have to total up the molar mass of this guy here. Now, nitrogen is 14. Water, or H, is hydrogen, and so it's 1 times 4 of them. And chlorine is 35.45. So you guys can total up that number. So it'd be 18 plus 35.45. So that's 53.45 moles.
Yep.
Or I should say grams, because again, and then we'll have to get so we'll have to divide that here. Okay, because that's in grams. So we want to convert it to moles. So we would do, just to make this a little bit easier, I'm going to write it in a different color so we know what we're doing. You're going to start with your 1.15 grams times 1 mole over 53.45 grams. Grams cancel out. We get our number in moles. That moles will go here, and then we'll divide it by 0.1 liters. So to get our number a little bit more making sense, if we do 1.15 divided by 53.45, we get 0.0215 moles. So if we did the molarity is 0.0215 moles over 0.1 liters, that would give us our molarity. And yes, I know this looks very, very messy. I apologize, but this is how you're going to work it. We first have to convert grams to moles. and we have to convert our milliliters to liters. Then we can just plug in the numbers and say molarity is the moles that we got divided by the liters that we got to get our answer. So if we were to do this, we would get, this is a 0.0215 divided by 0.1. And we got 0.215 M, which is the molarity or molar concentration. Okay, I know that looks super confusing, but they'll write it out a little bit nicer than I will. So again, we were told that we had 1.15 grams of this NH4Cl and that we have 100 milliliters. We need to convert grams to moles. So again, we use the molar mass to make this happen. So you do 1.15 divided by our molar mass of NH4Cl, and then we get the moles. For the liters, again, we had it in milliliters, so we need to make sure to get this number to be divided by 1,000 to get our liters. So that's what they're doing here, is they're taking the moles and they are just showing you how they cancel out the milliliters to get the liters. And it's how it comes out to this 0.215 moles. Let me show you a different problem. It might make life a little bit easier.
Yeah, I'm so confused.
All right, so again, what they're doing is they're not giving you the exact pieces. You have to make sure to convert first, and then you can plug it in. So first things that we have to do, we have 3.84 grams, and we need to convert this to moles. So how do we convert from grams to moles?
Get the mass number from the periodic table.
Very good. So you have 3.84 grams times 1 mole over that molar mass in grams. So now that gives us our moles. So if we went to the periodic table, you would have to find out the period or the molar mass of CrCl2.
So CR is 51,
Okay, 51.
and then CL
Is that 35.45
yeah.
times 2. So this comes out to be, and I'm going to fix this right here so you guys can see it in a little bit more detail. Cross that out. This is going to be 121.9 grams.
Oh, are you supposed to add like all the numbers on there, or you don't round it? So because CR is like 51.995, I think.
Okay, so it would be like 52 then. That's
Oh, they round it up. Okay.
yeah. And then we do 35.45 times 2. So yeah, 122.9. So it would be like 123 if it was all said and done. So we'll make this 123 grams. Make it easy. So the grams cancel out. So we get 3.84 divided by 123. And this comes out to be 0.0312 moles. And again, that's just one part. Now we have to convert this 125 milliliters into liters. Because remember, molarity is moles over the liters.
Will it be
So-
0.125?
Yep, it'd be 0.125 liters. So now all we have to do is just plug in our number. So we'll get this 0.312, 0.312 moles. Yep, over 125
You
liters.
just divide it.
Yep, we're gonna divide it. So now we have 0.0312 divided by 0.0125. And I got 2.496, which again, we're gonna round to 3 significant figures.
So 2.50.
Got it.
Wait. I got, oh wait, is it because you moved the decimal point? Because I technically got 0.2496.
Let me make sure, because I could have, let me just make sure I did this right. 3.84 divided by 123. And then we're gonna do divide that by, divided by 0.125. Yep, I got 0.249. I'm sorry. Yes, you were right. 0.249. And then again, it's like 6 or 7. So it becomes 0.250. If I can speak tonight, oh my goodness. I think that's why I'm doing this wrong. 0.250 M. And then we can submit our answer. So for this one, it's really a plug and chug once you convert from grams to moles and milliliters to liters. Then you just have to plug the numbers in, and that gives you your molar concentration. Now, the molar concentration is going to tell you how dilute or how concentrated something is. If you were looking at 0.25 M, that's actually kind of dilute, meaning that we added way more water to this guy than how many grams we had present in our molar concentration. But if we had like a 12 molar concentration, that would be very, very concentrated, not dilute. But therefore, we have a lot more of our sample and a lot less water to add to it. Now, let's do number 3 again, just to make sure that this makes sense. Okay, so question 3. A student weighs out a 12 or 10.2 grams of BaCl2 and then adds enough water to the 300 milliliters. So basically, again, we're starting with 10.2 grams and we're starting with 300 milliliters. We can really quickly convert milliliters to liters. So how what would this look like to make it to liters?
0.3.
Yep. 100 liters. But now we have to go from grams to moles. So we'll do 10.2 grams of our BaCl2, and we're going to do 1 mole over, and then where do we get the grams from, the BaCl2?
From the periodic table.
Periodic table, very good. So if we were to look at barium from the periodic table, what's its molar mass? Is it 137? Does that look right? I'm not looking at the periodic table in front of me right this moment. Yeah, 137.3 plus 35.45 times 2. So we do 137 plus 35.45 times 2. So that gives us 209.7 for this guy here. So we do 10.2 divided by 207.9. And I got, for this was 0.0491. Did everyone get that same answer? When we type this guy in?
So your moles are always on top and then the liters are on the bottom.
Yep, exactly. So when you go to then plug this in, we end up with 0.0491 divided by our 0.300 ml, or I'm sorry, L, because this is moles. So 0.0491 divided by 0.300. And what'd you guys get for an answer?
0.163. Well, technically 0.16.
64. Yeah, very good. So we put in 0.164. Submit, and then we get an answer. Do these kind of make sense a little bit from molarity?
Yeah.
So basically, again, you're going from grams to moles, going from milliliters to liters, and then you just put the moles on the top and you put the liters on the bottom. So, and like I said, if we want to, if anyone can make it on the Zoom call tomorrow, we can practice this again a little bit more tomorrow as well. All right, so for percent concentration, we kind of have already done this before. And we had talked about how you have like your particular element that you're looking at for the whole solution, if you will. Same kind of thing is happening here when we talk about percent concentration. We're going to figure out the weight over the weight percent, if you will, because we want to figure out basically what we have in our aqueous solution. And we're going to make sure that this kind of makes sense. So this says if an 18.7 grams of an aqueous solution ammonium chloride, so this is our whole aqueous solution, if you will, contains 1.1 grams just of ammonium chloride, meaning that the 18.7 grams is ammonium chloride and water put together. And we put 1.2 grams of just the ammonium chloride into this solution. It wants us to know the weight over the weight percent of ammonium chloride in the solution. So what we're going to do is we're going to take the weight of ammonium chloride and we're going to divide it by this 18.7 grams because this is of that solute and this is of the solution. Because we want to see how much is just the ammonium chloride in this entire solution. Because the solution here is the ammonium chloride plus water. This number is just advocating for ammonium chloride. What happens is the grams are going to cancel out and then we multiply by 100% to see what that percent concentration is. So when you go to type this in, we're going to do 1.12 divided by 18.7. And then we're going to multiply by 100%, which is just multiplying by 100. And I got 5.989%, which again, we want to take this to 3 significant figures. So this ends up being 6.00% by the time it's all said and done. So you take the solute itself, divide it by the solution, and then multiply by 100%. Does that kind of make sense here of what we're going to do? So you take your grams of your solute, the smaller quantity, divide it by your solution, which is mixing the two together, and then we multiply by 100.
Yeah, that makes sense.
All right, cool. So let's try the next one.
Sorry, I have a question.
Yeah, no problem.
For the midterm.
Mm-hmm.
So you know how like on the owls, if we're off by like point whatever, like how that one said the answer was 0.599 and you rounded it up to 6. On the midterm, is it going to mark us wrong if we round it up more than what it is?
So technically it'll be multiple choice. So you're going to see the answers ahead of time. Again, because I don't have it in front of me, I still haven't gotten access to the midterm. I'm going to say they're probably not going to be similar numbers. So you'll be able to differentiate between, okay, this is close enough, this was rounded up, and I can use this one. Versus it being like you have to mark it and it marks you wrong. Because yeah, it'll all be multiple choice. So I'm almost certain that it won't be anything too crazy. So we'll just have to, like I said, I'll know more hopefully tomorrow. Hopefully by tomorrow, Dean Kelly will have it actually set up for me so I can get into the midterm and see what it looks like. And then I can give you a little bit more of a example of it. I'll probably even show you guys on ExamSoft, to be honest with you, if I can get access to it. So that way you can see it. So hopefully, so bear with me. I will be able to answer that question, just not right this moment. But, all right, so let's do another one of these guys. It says an aqueous solution of chromium chloride, CrCl2, contains 4.9 grams of chromium chloride and 7.3 grams of water. What is the weight percent of chromium chloride in the solution? So basically what we're doing is we're getting the mass of the solute over the mass of the solution. And remember, the solution is the solute and the solvent together times 100%. So what is the mass of the solute here? What's the mass of our solute? Or what's that smaller number?
It's 4.90 grams.
Very good. Now, what this says here is that we contain 4.9 grams of this chromium chloride and 7.3 grams of water. Water's the solvent. So to make sure we get the mass of the solution, we have to do 4.9 grams plus 17.3 grams of that water. Because if we don't add that, now we are going to, we have to account for that now because we're doing the mass of the solute over the mass of the solution. And remember, the solute plus the solvent equals the solution. So now we cancel the grams out here and we're going to multiply by 100%. So I'm going to type it into the calculator as 4.90 divided by 4.90, and I have it in parentheses, plus 17.3. And then again, I'm going to multiply by 100 to get a percent concentration. So I get that this is 22.1%. So that's telling me that my solute is only 22.1. The water, the greater quantity, is almost 80% by the time it's all said and done. So this is 22.1%. Do these make a little bit more sense?
Like in the midterm, how do we know when to add them and when to not add them? You know,
It's just reading it's just reading how the question is set up. So like, for instance, for question 1, it says if 18 grams of an aqueous solution. So this tells you that this is your solution. With this guy here, what it said was that we had 4.9 grams of chromium chloride and 17 grams of water. It didn't say, and our aqueous solution was 17.3.
Okay.
It kind of, and it, without indicating that it's the solvent, it kind of tells you it's the solvent to add that together.
Okay.
Now, like this question here, if we were to look at it, an aqueous solution of barium chloride contains 4.23 grams of barium chloride and 17.7 grams of water. Is this the solution or is that the solvent?
Solvent.
Yeah. So to get the solution, we would have to add the two together. Yeah, very good. All right, so let's do this as our last problem for tonight. And then, like I said, I will do some more recordings. So we'll actually run through the rest of these so you guys will know how to do them before the midterm. So, and like I said, I'm going to do a study group tomorrow, and then I'll do a study group on Thursday. So I'll give you guys so you guys will know how to do these relatively pretty early so you guys can finish them up. Okay, so we do 4.23 grams because that's our mass of our solute, divided by 4.423 grams plus 17.7 multiplied by 100%. So again, when you go to type this in, 4.23 divided by 4.23. This doesn't want to work. Divided by 4.23 plus 17.7. And then I multiply by 100%. What did you guys get for the mass percent here? Or the percent concentration?
19.3.
19.3, good, percent. So that tells us how little solute we had and how much solvent we had total. So we had about 20% solute for 80% solvent within our solution. Okay, so we didn't get as far as I was hoping for, but that's okay. We went through quite a bit of the owls. So like I said, for tonight, we'll call it good. Tomorrow, I will answer any questions you guys have. And then if we don't have questions, I'll continue on with the owls to make sure we finish them up and get them ready to go. Depending on how far we get, I may have to make another recording, but you will definitely have the capacity to do all the owls. And then, like I said, hopefully I will hear more about the midterm. So I'll be able to show you guys a little glance of what that's going to look like. So if you can, come on tutoring tomorrow from 6 to 7 p.m. I will record it for you guys and I will post it to Canvas so you guys have it already ready to go. And then same thing for Thursday. I'll do another little recap. So are there any questions or concerns before we jump off? Any questions that we have to cover?
And we have the answers for them.
Like I said, due dates will change. You guys will get more practice and you guys get to use that equation sheet, that reference sheet. If I were you personally, I would print it off as soon as possible. So that way you get to see what it looks like, because you don't want to just go there that day and try to wing it. You want to make sure you look through it and know what it says. Write yourself as many notes as possible. So again, you have in your own terminology of how you can go from step A to step B to step C. You want to make sure you can practice that. So that would be my suggestion for it. And then, like I said, I will make you guys a little review on, okay, go over this, go over this, go over this, so you know what to practice for your midterm. So, all right, guys, well, if you don't have any questions, just feel free to jump off. Make sure if you did not type your name into the chat, you do, so that way I can mark you for attendance. And if you guys have any questions, stay on. If not, I will see you guys next week in class. I'm super excited about that.
Yeah.
So tutoring if you can be there. Otherwise, I'll see you next week.
All right, bye.
All right. Thanks, guys. I appreciate it.
I have this one
Bye.
question, and I'm pretty sure you said